is acceptable to install individual conductors in the conduit section between the meter base and the panel. This method is often preferred as it allows for greater flexibility and easier wire management. When preparing the neutral conductor for a 3-wire service, you have 2 options. Firstly, you can remove the outer jacket of service entrance cable and twist the bare neutral conductors tightly together. This method is cost-effective but does not provide as good protection against corrosion as using a covered conductor. Secondly, you can purchase individual insulated conductors, including a covered grounded conductor. This method provides better protection against corrosion and makes the installation cleaner and easier. It is recommended to use individual insulated conductors with a covered grounded conductor for optimal protection and ease of installation. The plastic bushing that protects the conductors at the incoming conduit sleeve section is called a cable entry bushing. It is designed to fit the specific size of conduit being used. When purchasing the cable entry bushing, make sure to specify the size of the conduit and the amp rating of the service, which is 200 amps in this case. When working with electrical systems, it's important to adhere to all applicable codes and regulations. Improper installation can lead to safety hazards and equipment damage. Always consult with a qualified electrician if you are unsure about any aspect of the installation. Single conductors offer advantages in terms of flexibility and ease of pulling through conduit, especially when dealing with bends and offsets. They also allow for a more organized and visually appealing installation. When using service entrance cable, the outer jacket provides a degree of mechanical protection for the insulated conductors. However, removing the jacket and installing the individual conductors and conduit provides even greater protection from physical damage and environmental factors. The neutral conductor plays a critical role in carrying unbalanced current back to the source. A properly installed and protected neutral conductor is essential for ensuring the safe and reliable operation of the electrical system. Twisting the bare neutral conductors together provides a low impedance path for current flow. However, it can be susceptible to corrosion over time, especially in damp or corrosive environments. Using a covered grounded conductor provides a barrier against corrosion and helps to maintain the integrity of the neutral connection. Cable entry bushings are designed to prevent abrasion and damage to the conductors as they enter the enclosure. They provide a smooth, rounded surface that minimizes stress on the insulation. When selecting a cable entry bushing, it's important to choose the correct size for the conduit and conductors being used. An undersized bushing can restrict the flow of current and create a potential fire hazard. An oversized bushing may not provide adequate protection. The amp rating of the service is a critical factor in determining the appropriate size of conductors and overcurrent protection devices. It's important to ensure that all components of the electrical system are rated to handle the maximum load. Working with electrical systems can be dangerous if proper precautions are not taken. Always to energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and regulations. If you're not comfortable working with electricity, it's best to leave it to a qualified electrician. They have the knowledge, skills, and experience to perform the work safely and correctly. Electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest requirements to ensure that your electrical installations are safe and compliant. Consider consulting with an electrical inspector to review your plans and ensure that your installation meets all applicable codes. Remember, safety should always be the top priority when working with electricity. Take your time, follow the instructions carefully, and don't hesitate to ask for help if you need it. A well-designed and properly installed electrical system is essential for providing safe and reliable power to your home or business. By following the guidelines outlined in this discussion, you can help ensure that your electrical system meets all applicable codes and regulations. In addition to the topics already discussed, it is also important to consider the type of conduit being used. There are several different types of conduit available, each with its own advantages and disadvantages. Some common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The type of conduit used will depend on the specific application and the environmental conditions. For example, rigid metal conduit is often used in areas where there is a risk of physical damage, while electrical metallic tubing is often used in concealed locations. It is also important to consider the grounding requirements for the electrical system. Grounding is the process of connecting the electrical system to the earth, which helps to protect against electrical shock and equipment damage. There are several different methods of grounding, each with its advantages and disadvantages. The method of grounding used will depend on the specific application and the applicable codes and regulations. Finally, it is important to consider the labeling requirements for the electrical system. Labeling is the process of identifying the different components of the electrical system, such as circuits, switches, and outlets. Proper labeling helps to ensure that the electrical system is operated and maintained safely. The labeling requirements will depend on the specific application and the applicable codes and regulations. In conclusion, installing single conductors and cable entry bushings requires careful planning and attention to detail. By following the guidelines outlined in this discussion, you can help ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember to always consult with a qualified electrician if you have any questions or concerns. The proper selection and installation of electrical components, including conductors, conduit, and bushings, are critical for ensuring the safety and reliability of an electrical system. Ignoring best practices or cutting corners can lead to serious consequences, including electrical shock, fire, and equipment damage. Take the time to understand the requirements of the electrical code and follow the manufacturer's instructions carefully. If you are unsure about any aspect of the installation, consult with a qualified electrician. They have the knowledge and experience to ensure that the work is done safely and correctly. In addition to the topics discussed, consider the importance of proper torquing of electrical connections. Loose connections can cause excessive heat, which can lead to insulation breakdown, arcing, and potentially fire. Use a calibrated torque wrench to tighten all connections to the manufacturer's specified torque. Also, be aware of the different types of wire connectors available. Use connectors that are specifically designed for the type of conductors being joined and the application. Avoid using wire nuts in areas where vibration is present, as they can loosen over time. Instead, use crimp-on connectors or other types of connectors that are designed to withstand vibration. Furthermore, when working with aluminum conductors, be sure to use an antioxidant compound to prevent corrosion. Aluminum is more susceptible to corrosion than copper, and corrosion can lead to increased resistance and heat. Apply a thin layer of antioxidant compound to the conductors before making the connection. Remember to always inspect the insulation on conductors for any signs of damage before installing them. Damaged insulation can create a path for current to leak to ground, which can be a safety hazard. If you find any damaged insulation, replace the conductor. When pulling conductors through conduit, use a lubricant to reduce friction. This will make it easier to pull the conductors and reduce the risk of damaging the insulation. Be careful not to use too much lubricant, as it can attract dirt and debris. After completing the installation, test the electrical system to ensure that it is working properly. Use a multimeter to check the voltage, current, and resistance of the circuits. Also, use a ground fault circuit interrupter tester to verify that the ground fault protection is working properly. Proper overcurrent protection is crucial for preventing damage to electrical equipment and wiring. Fuses and circuit breakers are designed to interrupt the flow of current when it exceeds a safe level. Be sure to use the correct size fuse or circuit breaker for the circuit. Using an oversized fuse or circuit breaker can allow excessive current to flow, which can damage the wiring and equipment. Undersized fuses are also not good. In addition to the above, always be mindful of the working space around electrical equipment. The electrical code requires a minimum amount of clear space in front of electrical panels and other equipment to allow for safe access and maintenance. Do not block this space with storage or other obstructions. Electrical safety is everyone's responsibility. By following these guidelines and taking the necessary precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. Remember, if you are not comfortable working with electricity, leave it to a qualified electrician. They have the training and experience to do the job safely and correctly. They also have the tools and equipment necessary to perform the work safely and efficiently. Finally, always be aware of the potential hazards associated with working with electricity. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. Be aware of the location of overhead power lines and underground utilities. Do not work near power lines or dig without first contacting the utility company to locate underground utilities. Wear appropriate personal protective equipment such as gloves and safety glasses. And always energize the circuit before working on any electrical equipment. Remember that a 200 amp service requires conductors and components rated for the amperage. Ensure that all conductors, conduit, and bushings are appropriately sized for the intended load. Refer to the National Electrical Code Table 310.15b16 for ampacities of insulated conductors rated up to and including 2000 volts. 60 degrees C through 90 degrees C. Also, remember that local codes may have additional requirements. It is essential to verify all local codes and regulations prior to commencing any electrical work. Furthermore, when installing conductors and conduit, consider the fill percentage. The National Electrical Code specifies the maximum percentage of the conduit that can be occupied by conductors. Exceeding the fill percentage can make it difficult to pull the conductors and can also damage the insulation. Ensure that you are using the correct type of conduit for the application. Different types of conduit have different properties such as resistance to corrosion, physical strength, and flexibility. Choose the conduit that is best suited for the environment in which it will be installed. Consider the use of pull boxes or junction boxes to make it easier to pull conductors through long runs of conduit. These boxes provide access points where you can stop and pull the conductors in sections. This can reduce the amount of force required to pull the conductors and can also prevent damage to the insulation. Remember that the grounded conductor, also known as the neutral conductor, must be identified by a white or grey color. This helps to distinguish it from the ungrounded conductors, which are typically black, red, or blue. Be sure to use the correct color-coded conductors when installing the electrical system. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection devices can help to prevent damage to computers, televisions, and other electronic devices caused by lightning strikes or other electrical disturbances. Consider using arc fault circuit interrupters to provide additional protection against electrical fires. Arc fault circuit interrupters are designed to detect arc faults, which are a common cause of electrical fires. They can help to prevent fires by interrupting the circuit when an arc fault is detected.